All right, so here is the practice test for your next test, which will be next class. Now you guys are pros at this, so I expect you to be ready. We're doing arithmetic and geometric sequences. So we're gonna have mixed answers between arithmetic answers, geometric answers, and equations and things of that. Okay, here we go. First problem says, determine if the following pattern is arithmetic, geometric, or neither. Again, arithmetic is adding or subtracting. Geometric is multiplying or dividing. If you already know this, then you can speed up the video to make it play a little bit faster and just kind of check your answers. If you don't know this, then you're actually following along. So the first thing you're going to do is figure out how your pattern is growing. This one is adding 10 every time. Well, if you're adding 10 every time, and you have to check a couple of them, then that's going to be arithmetic. This next one is multiplying by 3. Well, if you're multiplying by 3 every time, then that is geometric. Now this one, you're adding 1, you're adding 3, so we know it's not arithmetic. You're not multiplying, so this is actually neither. And there's lots of different types of patterns. This is actually a squared one. 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Okay, it's a quadratic. This one, it looks like from 7 to go to -3, you are subtracting 10 every time because you're subtracting. That is arithmetic. If you wanted to be a little bit neater, then the common difference is 10. The common ratio is 3, and the common difference is -10. All right, the next problem. Here we have, same thing, given the pattern, figure out which one it is. So it is growing up by ones, and make sure that this is going up by ones here because it could have a different pattern, and this is decreasing. And it looks like it's decreasing by 4 every time. And again, you do want to check a couple of them just to make sure that that's right. Okay, so this is definitely going to be arithmetic. If it's arithmetic, then it doesn't have this. It's going to be the y value over the x. So it is -4 over 1, which is -4. Your explicit equation, and you should have that one memorized. Our explicit equation for an arithmetic is this one. We'll use function notation. F of x equals, and we only need to plug in our m and our b. Our slope is -4, and our starting value is 25. All right, our next equation is f of x, recursive, just shows you how the pattern is growing. So we'll use this one here. And we just need to know the slope. So f of x equals f of x minus 1 plus -4, or I should have just written -4. So let me get some. -4 is probably a better answer. Let me get some white out, or either one. Okay, next so the next problem is this, and it definitely does look linear, so it looks arithmetic, but I'm still going to go ahead and make a table. You don't have to make a table, but sometimes it's a little bit easier to see. So I'm going to start with 0, 6, 2, 12, 4, 18, and you could have done -2, 0. Okay, so it looks like it's growing by 2 every time here, and this is going up by 6. Okay, so this is definitely a straight line, which makes it arithmetic. Then that means it doesn't have this, and it's not geometric. So the common difference, this one, be careful. The common difference is your y over your x, or if you do your rise over your run. The difference between 6 and 12 is 6. The difference between 0 and 2 is 2. So if that's not 1, look at the scale. That's actually 2. So your slope is 6 over 2 positive, and that reduces. 2 goes into 6 3 times. Explicit equation, it's still this one. So f of x equals your slope reduced 3x plus your starting value, and your starting value is at 6. Recursive, f of x equals the previous term plus your slope, and your slope is 3. All right, next equation, here we go. For this one, let's figure out the pattern. It says, let me see if I can zoom in a little bit. All right, so here we have, this one's going by ones. This one, adding 8, nope, you're not adding, so this is going to be a multiply by 5. Okay, if we're multiplying by 5, it means it is not arithmetic and it is geometric, so our common ratio is 5. Then I go to my notes for the explicit equation. Explicit equation, again, I can use the 0 term or my first term. I do have the 0 term, so I'm going to use that. 0 term is 2. Common ratio is 5. So f of x, 0 term is 2. Common ratio is 5. Oops. F of x equals 2 times your common ratio of 5 raised to the x power. Recursive equation is going to be this equation, so I'm going to copy it all straight down except my common ratio. Well, I know my common ratio is 5, so it's going to be f of x equals 5 times f of x minus 1. All right, next page. So for this problem, we can definitely see that that is not linear. So by the graph alone, we know it is not linear, so it's not arithmetic. This is definitely geometric. Now I have to figure out what it's multiplying by again. Well, because I know it's geometric, normally you would need more than one value, but you know that the graph is telling you that it's geometric, so we're just going to go from here, 5 to 15, same thing, you're multiplying by 3. So we know our common ratio is 3. Going to go to my formula. My formula says I have the 0 term, so if I have the 0 term, then f of x equals my 0 term, which is the starting value, 5, common ratio 3 to the x. Recursive is going to be just your common ratio, so common ratio is 3. So f of x equals 3 times the previous term. Nice. You guys are doing great. Okay, and this is all what they're going to do in Math 101 next year is arithmetic and geometric. And you have to distinguish between one and the other one. And the ones that I do are maybe a little bit simpler, but something a little bit harder is going to be what they do next year, but at least you'll be familiar with it. Okay, so let me pause the video and count all these dots so I don't take forever. So this is a nice problem. I already counted the dots. Some of you are a little bit more visual, so you can see that there's a group of 6 right there, 2 groups of 6 right there, 1, 2, 3, 4 groups of 6, or you could have said that's doubled that. Anyways, so I need to figure out my pattern. Well, on day 1, I have 6. On day 2, I have 12. I always make a table. You don't need the table, but it just makes it so much easier to see. So to go from here to here, you're going by ones. This one, adding 6, but that's not going to give you this. So this one is actually multiplying by 2 every time. Because you're multiplying, then again, that's geometric, and your common ratio is 2. An explicit equation, this is a good problem. For an explicit equation, in this case, you can see that I'm not going to use the zero term. I'm going to use the one with the first term because I don't have my zero term. This is telling you that this is day 1. I could figure it out, divide by 2 and it'd be 3, or just, you know, make less work for yourself. So f of x equals your first term. Your first term is 6. Common ratio, you're multiplying by 2 to the x minus 1. Okay, if you had used the other equation, then you would have had to figure out your zero term. And in that case, you would have said, okay, the zero term, if you divide by 2, is 3. So it still works. And you would have had another option for your explicit would have been this up here. F of x equals 3 times 2 to the x. Both of those equations are actually the same thing and they'll give you the same value. It's kind of interesting. Recursive, there's only one option. F of x equals, common ratio is 2 times f of x minus 1. Okay, you guys are doing great. All right, problem 10. It says Mr. Savola has $850 and saves $25 each month. Oops, let me try. So again, you don't have to do this, but this is really easy for me, is just to make a table. 0, 850. At the beginning, he has $850. So, and you should label your variables. This is month, and this is money. And again, we can just use X and Y, but you could use M and dollar for money. After 1 month, he saved $25, so now he has $875. After 2, he has $900, and you see the pattern is increasing by 25 every month. Okay, most of you did not need to do a table for that. You know this is linear, so it is arithmetic, and it has a common difference of positive 25. Your explicit equation is going to be your slope plus b, so f of x equals, your slope is 25 plus your starting value is $850. The recursive equation is f of x equals f of x minus 1 plus m. So f of x equals f of x minus 1, and your m is your slope or your common difference. So plus 25. That's a plus 25, not an equals. Looks ugly. All right, and the next problem says, how much will Mr. Savola have in 5 months? Well, variable, I forgot this variable x right here. Very important. Okay. So for that, what you're going to do is in 5 months, you use the explicit equation. The explicit equation will always tell you in 10 months, in 20 months, in 100 months, in 1,000,000 months, how much would you have? And all you're going to do is plug 5 right in there. I'm going to go ahead and use a calculator. So my output, if this is your x and this is your f of x, you're going to have f of x equals 25 times 5 plus 850. You can do the math in your head. You can use your calculator, either way. So this is, oops, let's do it all together. Okay, $975. The light's kind of light. So in 5 months, and wordy problems should have wordy answers. So in 5 months, Mr. Savola will have $975. Nice. Okay, next problem. It says, Mr. Rodriguez has $800. Yay. Okay. And I spend half of it each month. All right. So let's think about that. So I have $800 and I spend half of that each month. So after 1 month, I spent half. What's half of 800? 400. So how much do I have left? Good. Next month, I spend half of that, 200. So I have 200 left. The next month, I spent half of that. All right, so do you guys see the pattern? This is, it's dividing by 2. We are not allowed to divide by 2. We can only add or subtract for arithmetic, or we can multiply for geometric. So I can't say it's dividing by 2. I have to say it's the same thing as multiplying by 1 over 2. And let's just see if that works. 800 times 1 over 2. Yep, it's 400. Or 800 times 0.5. Same thing. Okay? All right, so we do know that this is multiplying. So it's not arithmetic, it's geometric. Common ratio is 1/2. My explicit equation is, I have the 0 term, so I'm just going to use this equation. Oh, there's the word where. And so f of x equals, 0 term value is 800, how much I started off with. Keep writing equals. Common ratio is 1/2. And because I use the 0 term, it's just to the x power. Recursive equation is this one. So I just need my common ratio. F of x equals, my common ratio is 1/2 times the previous term, f of x minus 1. All right, how much will Miss Rodriguez have in 5 months? You're going to use the explicit equation. So in 5 months, f of x equals 800 1/2 to the x. So there's 2 ways to do this. You can just use the equation, and in 5 months, you're going to plug in 5 right here. I'm going to go ahead and use my calculator. 800 times 1 by 2 raised to the 5th power. It is $25. Now, I could have, because it's only 5 months, I was already at 3 months. At 4 months, you know I'm going to have $50. And at 5 months, you know I'm going to have $25. I could have done it algebraically or use the table. But if I would have asked you, how much would I have in 20 months? You don't want to make a table for 20 months. Or will I even have any money left? Okay, so you can use the table or you can do this. And in 20 months, it says I would have this much money, but I probably would have wiped it out by then. Okay, we'll talk about that later. So, oh, did I give the final answer? And so after 5 months, wordy problems have wordy answers. After 5 months, I will have, Miss R will have $25 only. Okay, these next problems I know you guys love. So vocabulary, discrete means dots. Continuous means that you can draw it without lifting up your pencil. So this is definitely dots. They're discrete. Linear or nonlinear. It does have the shape of a line. So this is actually linear, even though it's not connecting. Only increasing, only decreasing, both increasing and decreasing, neither. So this is decreasing. If you were to write your name on this line, it would be going down. So it's decreasing. Function is if you draw a vertical line, it can only cross through one point. So it is a function. Nice. Okay, next one, let's see. Discrete or continuous? It is continuous. We can draw it without lifting up our pencil. Linear, nonlinear? It is not even close to a line. Both increasing and decreasing. If this were a roller coaster, you would be going up and you would be going down. It is a function. If you were to draw a vertical line through any part of the graph, it only intersects at one point, so it is a function. Okay, and next page. Same thing, discrete or continuous? Continuous, linear, nonlinear, definitely not a straight line, and it is both increasing and decreasing. And function, if you should draw a vertical line through any part of the graph, it is a function. All right, this one tends to confuse some of you. Discrete or continuous, they're dots, so it's discrete. This is actually linear, and you could argue it, but I'll say it's linear because it looks like a straight line. Is it only increasing? It's not going up, it's not going down. It's neither increasing or decreasing. This actually has a zero slope. Remember, a horizontal line has a zero slope. So that's a zero slope. Function, it is a function. If you were to draw a vertical line through any part of that graph, it is a function. All right, that is it. You are ready for your test, arithmetic and geometric sequences. Okay, good luck, guys.